Okay, so I gave the kids this ambiguous case problem. Now, did I give them enough information? Yes, because all you need is 3 pieces of info. 40-degree angle there, a 40 length side and a 35 length side, but it's ambiguous on which way that 35 would swing. Okay, so you have to try to figure out everything because you don't know exactly what I'm going to ask. Now, in this case, I'm going to ask for how long is this side right there, and so that brings us to you. What do you say I should do first? I agree. Let's find that angle. But which angle are you going to be finding? I'm going to give them letters. A, B, or C. Which one's going to actually come up? It would be C. It will be C. You don't ever get surprised by that because, think about this. Would you agree that that is an angle bigger than 90? You can't do inverse sine and ever get an answer where you're going to end up with an answer. Even 90 is too big. Okay, the biggest you can get is going to be a small, less than 90-degree angle. So if you're always going to get a less than 90-degree angle, you won't be getting this one. You'll be getting this one, which I'm not going to cross off B because it's actually the same. We'll get that angle right there. Okay, so tell me how you set that up. Sine 40 over 35. That's the beginning of the law of sines. Nice. Keep going. Sine of, I like it, we'll use C, over 40 because that's the side across from it. Okay, very nice. Save me some time because at this point I have to trust you can do this. That's a decimal. You divide it by 35. You multiply both sides by 40. And then you do inverse sine at the end. I love how I can say, oh, that's the easy part. Gloss over. Okay, if that's not easy enough for you, then you need to get a little more practice in. All right. So at the end, what did you get for that angle? 47.3. Can anybody verify they got the same thing? Okay, good. A lot of hands going up. So, and then that, as we said, is going to transfer over here. And then how do we know this one? It's supplementary. You even use the right word. I love it. So therefore, I subtract from 180, and I get what? Oopsie. Okay, I'm going to write it really small right here. 132.7 degrees. Awesome. Now, that's not what I asked for, but it helps me get there. Okay? The next thing I would do is not try to set up law sines. I mean, you can if you want to, but it's not going to work. You need one more piece of info, because if I need this green line down here, then I have to have the angle across from it. You can't have two variables, right? So help me. How did you get that? All the angles in the triangle at 180. Since they all add up to 180. 180 minus 40 minus 132.7, and you got what? 7.3 degrees. Very nice. And then now I'm ready to do another law of sines. So would you please tell me what that was? Nice. Okay. And then again, cross multiply. In this case, I do need to do the cross multiply thing because the x is on the bottom. Cross multiply, that times that equals this times this. Change sine 40 to a decimal. Change sine of 7.3 into a decimal. In the end, you solve for x, and you got... Oh, wait. Before I go there, it seemed like you might have a point here. Okay. Let me just finish and get the answer here, and then I'm going to try showing it your way. So would you tell me what you got? Final answer. 6.9. Can anybody verify they got 6.9? Okay, awesome. Now, this was just a suggestion from the back of the room. They said, I've been doing something different than cross-multiplying, and I'm open to that. So can you tell me, what were you doing to get that same answer as 6.9? So basically, you're saying you flipped both equations. when you put them to the power of -1, you're saying you flipped them, right? So then this is 35 over sine 40. And this one is x over sine of 7.3. And that's one of the reasons you are absolutely right, first of all. And why is it better? Because x is on top. That way I can just multiply both sides by sine of 7.3 and I'll be done. Okay, that makes me think of this. Do you remember me saying at the beginning that you can do it this way? Or you could flip it and do it this way. Do you get that that's the same exact thing, except flipped over, and that's legal to do? You can do that. So that's the law of sines also. If you just want to do it this way, if you have a side that's going to be the variable, you can do it this way. Same law of sines, you just write it upside down. Okay? So that's the same as you said, except if you went into it really good at this, you could go, if I'm solving for an angle, I'll use this law of sines. If I'm solving for a side, I'll use this law of sines. Now, what I just said was not critical. It's just an advanced step that he was suggesting, and he's right. Thank you. Okay, so that's it. Now, the cool part is today is called Law of Cosines. But because I hit that really hard on the first day, that means you already know the law of cosines, theoretically. Would you please write down a squared plus b squared and then finish the law of cosines from memory, I hope. Remember that this is not something I'm going to give you on the test, and therefore you do need to memorize it, because you'll be pretty stuck if you don't have this formula. Some thoughts on the difference between the law of cosines and the law of sines. The law of sines is easier. Okay, typically on the law of sines, I'm going to just count how many parts the law of sines has. I'm going to write it upside down. For some people, this is right side up. Do you get that? 1, 2, 3, 4 pieces. Okay. And then the rest, are you ever going to use all the parts at once? Nope. You're just going to need one other one, which I'm going to call B. And that's going to be little b over sine of big B. And that was 4 parts here. 1, 2, 3, 4 parts. Plus that, you could argue that's 9 parts to remember. 9 things to remember for the law of sines. But I think most of you guys know it's just easy to remember. Okay. The law of cosines has 14 parts. 14 things in a row that you have to know. Some of them are just things like squared, okay, but there's 14 things to write the law of cosines. Let's write it. So my point is, law of cosines is longer. Why would you ever use it? Because the law of cosines can you do all of the problems that we're going to give you. It's just that sometimes it's a pain to use it. It's got 14 parts, okay? But this, when you can use it, is a lot easier to use. And so you have the law of sines only because it's faster, but law of cosines can pretty much do everything. So it's more powerful. You should have said a squared plus b squared minus 2ab cosine of big C is equal to c squared. Now, I'm going to tell you something confusing. When you Google law of cosines, it often doesn't look like that. What? Because you could do law of cosines and rearrange it in a lot of different ways. Okay, so I'm just giving you the way that I feel like is the easiest way to remember. Because to me, this sets up so much like a squared plus b squared equals c squared, which you already know, right? And I always try to build on what you already know. And this is the easy way to me. Some of them have it solved for like a squared. Do you get, you could have this solved for a squared, and it would be a completely different looking formula that wouldn't just look like a squared plus b squared equals c squared. So this is just one of many ways you could organize this formula. It happens to be solved for c squared. Do you get, we could have even started with c squared is equal to blah, blah, blah. You know what I mean? I could just put a c squared equals over here. But then to me, it doesn't flow as nice because it's not a squared plus b squared equals c squared. Okay, so all I'm trying to say is if you were to Google this formula, it might look different than this, but I've got it arranged in the way that I think is easiest to memorize. All right. Now, do you remember that on this 14-part formula, only C really matters? Do you remember that? Just like when you were doing right triangles, the hypotenuse mattered and we had to call it C. Whether you call this A or B, it didn't matter. You could reverse those two. Same idea, but C is not the hypotenuse because these are not used on right triangles. So you can't just say C is going to be the longest side. Can't even say that. C is going to be the angle that is important in the problem. I'll give you an example. Let's say it's like this. Not a right triangle. Let's say this is 8. Let's say this is 9. And let's say this is, it's a pretty smallish angle, so I'm going to say it's 20 degrees. Would you please properly label this with A, B, and C? If this side's 8, this side's 9, and the angle's 20 degrees, properly label it with A, B, and C. And I mean big A, big B, and big C, and little a, little b, and little c. Here's all that really mattered, that you started with a big C right there. Do you get I don't care which side you call A and B? But if I call that big C, then this has to be little c. Right? And then the other two, they can be flip-flopped. How many of you guys put A up in the upper part? We tend to go from up to down, so I bet a lot of people put A there. And then probably a lot of people put B here. And that would make this little b and this little a. But again, your A and B can be reversed, and I'd be fine with that. And the problem would be fine with that, because look at it. Every time you have A and B, they're just right next to each other. Do you get if I'm going to square them and add them? It doesn't really matter what order they're in. Okay, so what's it all about? It's all about the C. So this is like a pirate's favorite formula, because it's all about the C. Get it?
Oh, yeah, now I get it.
All right. Like the ocean, except the sea. Okay. All right, all right. So let's try to use it once. Here's a typical, well, actually, why not use the problem we just had? It will make you not have to redraw a problem. Let's use this one, and let's figure out how long. No, actually, let's figure out how big angle A is. How big is angle A? Now notice, I don't have an angle on a side across from it. If I did, I would be using the law of sines right now. But I have what I like to call a side angle sandwich. Side angle side. I have a side, and then the angle, and then the other side. Once you know this formula, is it going to instantly solve for big A? No, it is not. What's it going to solve for? It's going to solve for side C. Why does that even help us that it solves for side C? Because then you'll have a side and an angle, and then you can use the other formula, law of sines, because it'll be a lot easier. All right, notice I labeled it with the A being 9, but again, if you did it with the B as 9, that's totally fine. It's going to work out the same. Okay, so 9 squared is 81, plus my B is 8, so that's 64, minus 2 times 9 times 8, and those can be reversed, doesn't matter. Cosine of 20 equals C squared. Common mistake is to do all of this work and then not notice that your answer needs to be square rooted. Do you get we need to take square root at the end? Because we have a c squared here. So you're going to square root your answer at the end. Take the time, type it all the way in. See if you get the same thing as your partner sitting next to you. Okay, at this point, I want to watch out for a trap. Kid goes and types in this just directly in order from left to right. It actually would be okay. The trap would be if the kid subtracts these two first and then times, you get why you can't subtract those two first? Order of operations. If you just go 144 minus, or 145 minus 144, you're going to get 1, and then, oh, cool, 1 times 0.9. That doesn't work. Okay, you can't subtract first and then multiply. You've got to multiply first. So if I just type it all the way in, 145 minus 144 times, notice how many decimal places I used. A lot. Because I didn't want to be accused of rounding it too much and then getting the wrong answer because of that. And then, do you get why when a kid gets 9.68, they think, oh, cool, that's the side must be 9.68. Why is that wrong? Square root. Got to square root that. So I'm going to go second square root that answer. I'm going to do second answer, and I have 3.11. So C is 3.11. If you're extra sharp, you know that it's positive and negative, but then if you're really extra sharp, you'll know that one of those must be extraneous because a negative length of a side can't be. All right. So, cool. We just did a lot of work to find something we didn't need. I mean, we were asked what the angle A was, and in the end, we found that C was 3.11. How does that even help? Because now you can do law of sines to figure out A. But I know you know how to do that, and so I think I can just say, period, use the law of sines. So with no extra help, please figure out what A is. Use the law of sines. And I'll pause for a second while you give that a shot. All right, so, got an answer? Oh, question first? Yes, go ahead.
So I felt like my A and my E.
Yes, if those, then that's because you found B instead of A. All right, so she was asking if you reversed these two, then if you reversed those two, then obviously you didn't find A, you found B. Okay, it doesn't matter, you found one of the legs. All right, so now we want to figure out what the final answer is for the angle A, and kids said they've already done the work on this one, so let's get the final answer. I betcha you lose law of sines, so please just tell me, random person, row 2, person 5, 1, 2, 3, 4, 5, that's you in the back there, CP, sorry. P is silent though, so anyway. What did you get? Sine of, tell me through this, sine of what over what? Sine of 20 over equals, nice. And then when I'm going to trust you to cross multiply, solve inverse sine, and you got 81.8. Raise your hand if you had 81.8 or it would have rounded. Okay, good. Awesome. Now, is there any other way we could have done this faster? Yes, but it's going to take a little bit of outside the box thinking. I'm going to back up and act like I was just starting this problem over again. You know what? Not in your first day. There is another way to do this, but you're not ready for it yet. I'll try to get there eventually. I don't want to leave you confused, okay? You have a way. It'll work. It'll work for the whole test. It's fine. Okay, but it's not as easy and quick as Parker's way that we just did a minute ago where we can just flip the formula upside down. It's not that. It is rearranging the formula, but it's complicated, and it's not worth it right now. Don't want to confuse you. Then I want to take another moment. It's 12-minute warning. Then that's keeping me from taking that extra moment. instead, 12-minute warning says get them into the homework so they have some time to work. All right, so let's get into the homework. I'm going to pause for a second while we get. So as that was loading up, I was thinking to myself, okay, so I've already taught them law of sines. I've taught them law of cosines. I've taught them about the ambiguous case. I was thinking to myself, what else is there? And I can only think of one more thing that I really need to make sure you know, and that's about finding the area of a not right triangle. And I briefly mentioned the formula the other day so that I could say I talked about all the formulas. And that was the area of a triangle is 1/2 A. Can you finish it? 1/2 AB. No, I said that there was only one formula that had cosine in it. Okay, you were really close though. So say it one more time right. 1/2 AB sine C. And one more thought on that. A formula that only has one side is not a formula. We need to say A equals. Very good. And just to clarify, that's area. Let's write area. Otherwise, you might think it's side A or something. Area is 1/2 AB sine C. Now, I think on this assignment, it might be thrown in only once in one little spot. But I realized we actually test them on area of those triangles. So I better make sure I start mentioning it again right now. That you need to know that formula to find area. Because it is a super simple formula. It's way simpler than the law of cosines or the law of sines. Let's just do one with this. So once I'll start problem 1 with you. And once we get it set up right, we'll find its area. And you'll see it. It won't be hard. Okay. This says AB and angle. Remember me saying what that was? It's a Greek letter C. So that's like capital C. Okay. Which of these angles to you looks like it's a 59-degree angle? Because you don't want to slap in a 59-degree angle here where it's obviously that's like bigger than 90. That can't be 59.3. Do you see what I'm saying? And isn't this a pretty small angle, more like 30-ish? So I think I've narrowed it down for you. This one right there ought to be our 59.3-degree angle. Next, if that's C, I encourage you to change it to a C. I don't need you to memorize Greek. Unfortunately, I need you to know that that is a C. All right. Then A and B. Now looking at the other spots, if I call this A, then I'm saying that is little a. And if I call that B, I'm saying that this is little b. So which one looks more like a 7 and which one looks more like a 12? Does this side here compared to this side here, remember I'm not touching that one because that's side C. Do you see how one of them looks like it's more like 12 and one looks more like 7? Do you get a kid who just slaps them on here and goes 7, 12? It's not going to work out very nice because those aren't right. The 7 side is longer, so you really ought to make that the 12. So that's going to be 12, and that's going to be 7. So it takes a minute just to set these up. But do you see I have a side angle sandwich? So it's a perfect setup for law of cosines. If I had an angle on the side across from it, I'd be thinking law of sines. So this is law of cosines. But wait. Just for a second, I encourage you to take a minute and try one area problem. You're going to need to know this. Let's find the area of this thing. So the area is 1/2 A, which is it says what A is, 7, times B, which is 12, times sine of C, which is 59.3. Do you get how that's just plug it in the calculator now and you got the answer? See how easy that is? Do you get how that might be handy on the ACT test? This is one that not often, but does come up. And if you happen to know this formula, you got a huge advantage over the other kids because the other kids are going to have to make this into a right triangle and maybe 2 right triangles, and they're going to have a lot more difficulty because they'll have to find the height of it. You know what I mean? And then they'll have to do the base times height and divide by 2, or they'll have to divide into 2 triangles and add them together, and you would be able to just do this super simple zip done. Okay. All right. So that was a quick moment for area. Now let's get into this final actual answer. What do they want to know? the remaining sides and angles if possible. What does that if possible mean? Isn't there a chance that there's triangles that don't exist? Don't forget, if you're like racking your brain for, why am I doing this wrong? It's not working. Maybe the answer is no solution. Or maybe you just set it up wrong. But at least know that it's possible. It's no solution. All right, so everybody, your homework's that and that. And this one, I think we should do both on that page. That'd be 4 problems. And let's just do, actually that's a little too much because I'm going to assign something else. Let's cross off number 8 here. And we are going to need to do a word problem. And I like this one. You don't think about the hands of a clock forming an angle very often, but they do. And do you get that the total is 360? And then if I wanted to know how big that angle was, do you get it's something out of 360? And then, well, there's actually only 60 minutes in an hour, Mr. Server. You're right. So then some number of minutes out of 60, you can like convert that over to like out of 360. So it's not too bad, but it's not too often that we talk about how a clock has an angle between the two hands. So again, figure out how many minutes it is out of 60 minutes, and then you'll be able to convert that into how many degrees it is out of 360. I need you to be smart enough to handle that. All right. And this is an awesome question, but it's awesome enough that we're going to do it in class, so we can save that one. You don't have to do it as homework. Trying to keep your homework reasonable. So, do it up through number 18, and that's all I have for you for today.